Our next speaker, his mom and dad always called him Cole. Ladies and gentlemen, Steve Cole. Yay!
Okay, well, my name is Steve Gold, and I teach 4th and 5th Sunday school here.
Can you hold the mic up higher?
Can you hear me now? I can hear me, so okay. So I'm a teacher here, 4th and 5th Sunday school, and I like to inject into my lessons for the 9 and 10-year-olds something about creation or just something to confirm the validity of the Bible every week, just so that these kids are equipped. They're not going to be defenseless when they get into junior high school and so on. We want to, and all of us need that, just confirmation that something that we can just grab onto to prove that the Bible is trustworthy and valid and infallible. So I try to put in a creation lesson, and we talk about proofs of a young earth. We talk about the physical evidence of the flood of Noah, and we talk about the Ten Commandments. We go through the commandments one at a time to prove to the kids that they are in violation of every one of those 10 commandments. And I tell them about how that's defined as sin, and we cannot stand in the presence of a holy God if we have sin. So we're separated from God, and that's why Jesus Christ came. If we believe in Him, we can transfer our sins to Him. He suffered and died on the cross for us, and if we just confess and repent, accept Him as Lord and Savior, ask the Lord to come into our hearts, we'll be saved and born again. So we do those kind of things in the class. And anyway, I had a presentation on Mathew Maury a few months ago. It was so fun and so interesting that I was talking to Bill about it after second service, and so I was invited to give it here, so here we are. Okay, so this is Mathew Maury. He was born in 1806. I didn't even know about him till I was researching, and I was just blown away by this guy. I won't go through everything that's listed here, but I will mention a few things. He wrote the first book on nautical science by an American naval officer, the first superintendent of U.S. Naval Observatory, first hydrographer. Thank you. Okay, precursor of the U.S. Weather Bureau, founder of science, oceanography, founder of the science of oceanography, father of meteorology, pathfinder of the seas. That refers to Psalm 8:8, where he read pathfinder of paths in the sea. And as a nautical man and interested in the ocean, he understood if God said it, it's there. So it was just up to him to try to discover it. And so in his pursuit of doing that, we'll see how the Lord blessed that and how the whole world benefited from that. Okay, he located the best position on the ocean floor to lay the first transatlantic cable. He was very instrumental in establishing the Naval Academy, and just on and on. So he's quite an interesting person. Obviously, we're not going to be able to cover everything about him. Here's a photo of him. And these are the kind of ships that were being used in his time. So obviously, if you don't have wind, you don't go anywhere. So, and I know there may be young people here. I don't know how many young people are here, but I see somebody who's young. Okay, so anyway, these are the kind of ships that we had back in those days. If you wanted to get a letter to somebody in England, it had to go on a ship like that. He was called the Pathfinder of the Seas. That was his common nickname because he saw in Psalm 8, if we look down here in bold, the fowl of the air and all the fish of the sea and whatever passes through the paths of the seas. So Psalm 8 is a psalm of worship to the Lord. I'm just showing this because this is the part that's relevant to our lesson. But of course, the whole psalm is a blessing to read and to use to worship God. All right, so I'm just going to talk a little bit about Mathew Maury, and we'll talk something about his life. All right, so he was born in 1806, and so if I know we have, I don't know how many young people we have, and it's kind of hard to figure out how long ago that would have been. I'm 75 years old, and I'm a great-grandpa. So he would have been born about almost 3 grandpas ago. So if that helps. Okay, so he was, his father was a poor farmer, so he had a very poor land. That's all he could afford. Everybody had to work very hard just to scratch a living out. And Mathew Maury was not really, he didn't have expectation of doing anything except being a farmer. His dad told him, "You're going to be a farmer." He couldn't go to school. All he did was work in the field. His older brother somehow got away from the farm and joined the Navy, and when Mathew was 8 years old. And he would come back from these long cruises and talk to Mathew, and he just had these wonderful visions of being a sailor like his big brother, and he just dreamed about going to sea. At 12 years old, he fell out of a tree, and he was disabled and injured and was not able to work in the fields. And as far as his dad was concerned, he was useless. And so he decided, well, he can't work in the field, might as well send him to school. Maybe it'd be worth something. So he sent him to school. He went on from school to college, and at 19 he joined the Navy as a midshipman. And a midshipman, if you know about it, in those days, a midshipman is the lowest level of naval officer. These are young people that go on. They didn't have a naval academy at that time. They would go aboard ship, and they would learn from an instructor there and just follow around the officers and just learn from experience. And I don't know if any of you have ever seen the movie Officer and Commander. It's a wonderful movie about that era. It was about a British warship, but you really get a taste and the feeling of what shipboard life was like in that era. I would recommend seeing that movie. It's a great family movie. So anyway, he went aboard, and the reason I call him midshipman is because the midships, the middle of the ship, is where the least movement is. If a ship is rocking, if you can imagine a teeter-totter, the fulcrum is stable. So that was kind of where they put the midshipmen, so they at least wouldn't be so sick that they couldn't listen to a lesson. So on his first cruise, he was really excited about going on his first cruise as a midshipman. He just wanted to learn as much as he could about the ocean. And he was just sorely disappointed and frustrated because there was really no instruction worth anything. The charts, the maps were totally inadequate. And he found out that on that trip that the only way you really learn about sailing is just from experience. You just learn from the older ones. There's really nothing to learn. You just pick it up as you go. And so he, as a brilliant, smart young guy, was very frustrated and disappointed. And he found out also that it was treacherous to be at sea. Once you go beyond sight of land, all you see is water. And unless you can navigate, unless you have some idea of how to get to your destination, you can't really tell much. So, and in those days, we're going to see a video in a couple of minutes if it plays, where the guy is talking about ships getting stuck in becalmed waters. That's very still waters where there's no wind. And they could be stuck there for weeks at a time, just stuck. So there was a desperate need for some way, a dependable way of navigation, but it just didn't exist at that time. So all right, so in 1830, he went on his second cruise. Now that cruise happened to be, it turned out to be a historical cruise where they were the first U.S. naval sailing ship to circumnavigate the globe. So here he was, brand new, and the Lord put him on this ship to learn how to sail, and on this extended, long voyage going through all these oceans, going to all these different countries, and seeing a vast assortment of different conditions. It turns out that the captain had no use for the instructor. He thought the instructor was just an extra mouth to feed. He didn't do any work, and he couldn't see any value in it, and he kicked him off the ship. So here's Mathew Maury, a midshipman, there to learn, no instructor. But fortunately, there was a library aboard ship, and from that point on, he self-instructed himself. So he learned more about sailing than any instructor could have taught him, just by having a brilliant mind and a strong desire to learn. And he actually, in his spare time, chalked out on cannonballs spherical geometry problems. And he taught himself spherical geometry, which, of course, is so applicable to navigating on Earth. And he was like the only person that even learned about that. He just did it by experimentation, by being stuck on his own. After that, he made one more cruise, and this time as a sailing master. So he had made so much progress just on that cruise and some extra things that he did between cruises. On the last cruise, he actually was the second in command, and he was called the sailing master. So he was in charge of all the charts, all the navigation. The captain, of course, was the guy who ran the ship, but Mathew Maury was a guy who really was the second there. After that cruise, he went on leave. He had a family. He was visiting his family, and he suffered a tragic stagecoach accident, and his leg was crushed, and he became permanently disabled and unfit for sea duty at that point. That's the second. Now, think about it. The first time he fell out of a tree, all right? Second time a stagecoach fell on him and he crushed his leg. I'm sure that he hated that, but the Lord had a plan for him, and we learn about these people, and we see how their lives progress, and it turns out that the Lord had other things in mind for him besides being a sea captain. So after his injury, he was placed in charge of the U.S. depot of charts and instruments. So this is the place where all of the old sea logs and charts and maps and instruments all come, and they just kind of just keep them there. They were just a dusty old place full of these old neglected old charts and things. And this was, it was here that he determined to discover the paths of the sea. And again, he knew It was in the Bible. He knew it was true. It was just up to somebody to find them. And so he determined he was going to be the guy to find them. And he analyzed. He started out, there was so much there. To narrow it down, he just gathered up all of this information, and he narrowed his studies down to the most important commercial sea lanes. And actually, at that time, a major sea destination was from Baltimore to Rio de Janeiro. And in those days, it took about 75 days one way, each way, to go from Baltimore to Rio de Janeiro. And they would bring flour down to Brazil and then bring coffee back up, from there. After he did his analysis and gathered all this information, he was able to make a new chart, and instead of being 75 days each way, it was about 37 days down, about 38 days up. So he just about cut the transport time in half. Now, in those days, they calculated the cost of shipping by per ton day. So you can imagine what a tremendous savings that was. All right, here's just a copy of the first book that he wrote. This was on winds and currents, and this was like revolutionary. This was the type of charts that he had for that Baltimore to Rio de Janeiro. So this was revolutionary. Here's a copy of one of the pages, and you can see this chart with these lines. Those are wind currents. So just having that available was a tremendous asset to American sailing. This is his second book, and this was really a famous book, The Physical Geography of the Sea. And when I saw this, I really didn't understand how can you really have geography in the ocean, until I realized that he had actually, besides charting the ocean currents and the wind currents, he actually also charted the bottom of the sea, and he used sounding. Now, I didn't know how you could use sounding in those days before the technology that we have now. I've heard of sending sound down to the bottom and then measuring the time it takes to come back to get an idea of the depth, but I didn't know they had sounding back then. But all right, that's just the introduction to that book. And by the way, before we go on, that book is public domain. If you were just to Google physical geography of the sea, you'll get a copy of that book for free. And it's a wonderful scan. Every page is great, and it's so delightful to read. We really don't have a lot of time, so I'm not going to go read from it. But believe me, it's worth looking at. Okay, so soundings. All right. I'll just read this. In 1850, a tugboat laid a telegraph cable between England and France, and the search was then on for the smoothest and most level seabed routes for other telegraph cables. Here's a painting of what it looked like when they laid that first cable. So this is a sea-going tug, a British tug. Actually, it was named the Goliath, and it's, as you can see, it's a big steam boiler and paddle wheels, and you can see the big, huge reel there, and they're paying out the cable. And so once that happened, this was revolutionary. You now had instant communication between England and the continent of Europe. So once that happened and it worked, then there was a demand for these cables everywhere. So there was a big push for a transatlantic cable to connect the United States with England. So Mathew Maury was asked to help determine the best location to lay the transatlantic cable, and he had 3 surveying vessels under his control carrying out deep sea surveys. And using a variety of ropes, so picture this in your mind, a variety of ropes and lines stowed on reels on deck, they took a large number of ocean soundings from which they brought seabed samples. How'd they do that? They use sounders. Okay, the one on the left is an earlier model. That would be suspended at the bottom of a rope, a cable, and lowered down to the seabed. Of course, they would measure how much cable it was, and that would give them the depth. And then that little device down at the bottom would sink down into the sand, or it looks like they might drag it along, and then when they pulled it back up, it would have a little sample of what the material was on the seabed. So they learned 2 things. They learned the depth, and they learned something about the nature of the ground itself under the sea. The one on the right is a more advanced model. This was actually invented by a midshipman. And you can see on the left, it looks like it might even been, it looks like it might have been a modified cannonball, but it has a hole drilled through the middle of it, and there's a tube, a hollow tube going down through it. It's held, it's suspended on that little contrivance up above it, and as long as the weight of the ball is pulling down, it keeps it locked in place. The middle one shows when it hits the bottom, then the line becomes slack, it releases the mechanism, and the ball slips off and stays on the seafloor. And then the third one, they pull up the rod by itself. When they pulled the rod up, they had double confirmation that they had actually hit the ground because the ball wasn't there, and they also had a sample in the tube of the seafloor. So now we know what soundings are. Okay, okay, this is a video. Let's hope it plays.
Psalm 8 extols the paths of the seas. It was a favorite verse for Mathew Maury, who became known as the pathfinder of the seas.
He was able to codify something that everybody thought defied explanation.
Mariners had, for centuries, realized that there was currents in the ocean. No one had, up until the time of Maury, systematically analyzed those currents to best take advantage of them.
A Virginia farm boy, Maury was never schooled until age 12 when he fell out of a tree, severely injuring his back.
His farmer father, Richard Maury, feels that his son can't help in the field. He would salvage something out of this. He would send young Mathew to school. And it's there that Maury becomes injected with this love of knowledge.
In 1825, Maury joined the U.S. Navy and took his first voyage. He was fascinated by the sea and shocked to discover just how little was known about navigation.
It was very common in those days for ships to enter latitudes where they were becalmed. They would literally have no wind for weeks on end, and they were powerless to move.
Maury began writing about navigation while he pursued his goal of commanding at sea. But in 1839, a stagecoach accident crushed his leg, ending his sea career and landing him in the Navy's depot of charts and records.
For a young officer like Maury, this was a career-ending assignment.
But God had other plans.
When he arrived, he was horrified at the condition of the charts, some of them being over 100 years old.
And so Maury's life work began. He determined, as noted in his beloved Psalm 8, that there truly were paths in the seas. By analyzing the Navy's charts and requiring new documentation aboard ship, he charted the ocean's currents and revolutionized travel.
Maury's findings affected business immediately, cutting sailing times by weeks, even months on long voyages, and saving millions in the process.
The commercial impact of this is phenomenal. It's almost as if jet planes had been introduced to transatlantic travel.
We began to compete with and outstrip the commercial nations of old Europe, and the Dutch, the British, the French, and American goods and services were everywhere.
Maury would go on to publish his findings for all to share. researching not just the ocean currents, but the wind and stars as well.
He was the most internationally recognized scientist of his time, rivaling Benjamin Franklin in his own time.
But in the midst of his fame, Maury was not shy about expressing his faith. In a time when Charles Darwin was drawing attention for his theory on evolution, Maury proclaimed the Bible as scientifically accurate. The Bible, he said, is true, and science is true, and therefore each, the truth of the other if truly read, but proves the truth of each other.
Maury always felt that his revelation was simply pulling back the curtain of God's design.
It's fitting then that monuments to Maury today clearly display his Bible and note the inspiration it provided. Heather Sells, CBN News.
Okay, well, if you noticed a little repetition there, remember, I'm a 4th and 5th grade teacher, so repetition is a good thing sometimes. Okay, here's an example of what a chart would kind of look like. You'll notice that there's blue lines, these are wind charts, and there's red ones. So the red ones are closer to the middle, that's the equatorial ones, it's hotter there, and the blue ones are the cold winds from the poles. And we're going to learn a little bit about what makes those winds blow. So we'll move on here. All right, we're going to see a movie here, and it goes kind of fast. I kind of geared this talk to 4th and 5th graders because I didn't know who was going to be here, and so it doesn't hurt us to learn stuff on a 4th and 5th grade level sometimes. So what these are stills from a movie that I'm going to show you from NASA, and I just want to it goes fast in the movie, so I just want to kind of talk about a couple of these scenes just so that you're prepared for it and you might get a little bit more out of it. Okay, the first slide shows the solar wind from the sun, and okay, that actually engulfs the entire solar system, and it protects our solar system from cosmic rays from outer space. So that's the first line of defense that God gave us in our solar system. Now, just because we are in the solar wind, we're not completely safe, because there's events that happen on the sun that can be very deadly. And this is an illustration of a coronal mass ejection, or a CME. These are periodic bursts of energy from the sun where parts of the corona will just fly out into space. And this little section here is showing, here's this CME heading toward Venus, all right? Now here's Venus. Venus is just there, and it's fully exposed to this CME. And when it hits Venus, it will strip away any atmosphere. It just leaves all this just terrible toxic soup there. In contrast, this isn't too good of a photo, but this is you can't really see it that well, but it's the Earth, and the Earth is deflecting that CME radiation. The reason it does that is because the Earth has a magnetic field. Venus doesn't have that. So the Earth, when the Lord put us here, He did it in a way that is going to be totally fine-tuned. And there's studies, I don't know if you are familiar with a video called Privileged Planet. It's something we have in the bookstore. It talks about all of these different ways that the Lord fine-tuned our earth so that it's inhabitable by us. The odds of this happening by accident are just so beyond miraculous that it's incalculable. All right, here's it's going to show wind currents, and you see how those currents kind of weave and wave all through the earth. It's going to talk about that. and it has little arrows to kind of show the direction. It's really going to be a cool animation. All right, here this shows wind-driven ocean currents. So when we look at ocean currents, there's different layers, different levels of ocean currents. The ones on the surface are driven by wind. And if you'll notice, there's some of these curlicues there that look like 8s. And you can remember Psalm 8:8 if you remember what those look like. All right, let's play this video.
What safeguards our solar system is our star. The sun provides a shield stretching beyond the last planet in its orbit, a force field that deflects these cosmic rays. But these solar winds can be dangerous too, especially during outbursts called coronal mass ejections. Want a vision of Earth gone wrong? Just look at what solar storms do to our sister planet, Venus. They strip away lighter elements in its upper atmosphere, hydrogen, oxygen, and the molecule they form, water. What's left is a witch's brew of noxious chemicals, including thick, sulfurous clouds. How has Earth avoided the grim fate of Venus? We can see the answer as the solar storm approaches Earth. Our planet has a protective shield all its own, a powerful magnetic field generated deep within its core. In fact, that's just our first line of defense. Much of the solar energy that gets through is reflected back to space by clouds, ice, and snow. The energy that Earth absorbs is just enough to power a remarkable planetary engine, the climate. It's set in motion by the unevenness of solar heating, due in part to the cycles of day and night, and the seasons that cause warm, tropical winds to blow toward the poles, and cold polar air toward the equator. Wind currents drive surface ocean currents. This computer simulation shows the Gulf Stream winding its way along the coast of North America. This great ocean river carries enough heat energy to power the industrial world 100 times over. It breaks down in massive whirlpools that spread warm tropical waters over northern seas. Below the surface, they mix with cold, deep currents that swirl around undersea ledges and mountains. Earth's climate engine has countless moving parts: tides and terrain, crosswinds and currents, all working to equalize temperatures around the globe.
Wasn't that beautiful? Okay, so it showed us these currents, but didn't really explain how they work or why they're there or how they got there. So let's go ahead and we're going to find out about what a convection current is. All right, so here's a pot of water on a flame, and you can see that the flame is hotter in the middle of the pot than it is on the outsides. The hottest part in the whole pot is at the bottom in the middle. And you see these red arrows coming up from the middle. That's the hottest water. And the hottest water is going to rise. The coolest water in that pot is on the outside. And as the hot water rises, that forces the cool water to circulate. And this is a convection current. All right? It works with fluids. It works with water, and it works with air. So here's a question. Which one is the heaviest? There's a bucket of hot water and a bucket of cold water.
Cold.
Which one?
Cold.
It's a cold one. Why would the cold one be heavier than the hot one? Remember, the hot air rises because it's lighter. Why is it lighter? Because the molecules are farther apart because they're heated up. So the cold ones, you know, when you get cold, you huddle together. Okay, well, that's what the water molecules do too, and they sink down. So that causes a circulation. We call that a convection current. All right, now here's the Earth. And you can see, of course, that the Earth is a sphere, and the closest part is the tropic, right in the middle. And it's not hotter necessarily because it's closer, but it is fully exposed to all the radiation from the sun that's hitting it. So it's going to be the hottest spot. At the poles, the rays from the sun are at an angle. So they're going to glance off. They're not going to be as strong. And so the poles are colder. And from what we just learned about convection currents, we can see that that's going to set up a current. All right, here's a little illustration. This shows hot water rising, cold water sinking, and there's something else on the right. That's salt. That's salinity. We know that the ocean is salty, and it turns out that there's variations of salinity. Salinity just means the degree of salt. So there's situations in the ocean where the ocean is saltier in some areas than the other because of evaporation. If salt water evaporates, the salt doesn't evaporate, the salt stays in the water, so the salt gets more concentrated in those areas. In other areas where it gets a lot of fresh water coming in, it might be more diluted than it would be in other areas. So again, we have heavier salt water sinking and the lighter salt water rising, setting up a convection current. All right, here's another video.
Ocean currents. The third type of movement that takes place in the oceans is known as an ocean current. Streams of water move along the surface of the ocean in definite paths. Such more or less permanent streams of water which flows in a definite direction from one part of the ocean to the other are called ocean currents. Ocean currents can be thousands of kilometers in length and sometimes about 200 kilometers wide. Currents that originate near the equator and flow towards the poles are called warm currents, and those which originate in the high altitudes and flow towards the equator are called cold currents. Ocean currents are generally named after the regions along which they flow. The warm ocean current flowing along the Brazilian coast is called the Brazilian current, and the cold current flowing along the Labrador coast is known as the Labrador current. Ocean currents are powered by the wind system of the world. The wind systems of the world force the surface water of the oceans to move in a particular direction. A surface current of warm and light water flows from the equatorial region towards the polar region, and a cold current flows from the cold polar regions to the warm equatorial region. The prevailing winds lend speed and direction to a mass of water. Ocean currents in the northern hemisphere deflect to the right of the wind direction, and currents in the southern hemisphere deflect to the left. Therefore, there is a clockwise circulation of water in the northern hemisphere and an anti-clockwise circulation in the southern hemisphere. This is a Coriolis effect caused due to the rotation of the Earth.
All right, I didn't want to get too much in the weeds on this, but I thought this was interesting. So let's do the other one. I kind of cut these down and just kind of keep the highlights on it, but I thought it would be interesting for you.
The ocean conveyor belt and the Gulf Stream. Ocean currents have a direct influence on our lives. They determine our weather, our climate, and much more. The ocean currents and wind systems transport heat from the equator to the poles and operate like a large engine for the global climate. In the oceans, there are numerous currents. The so-called ocean conveyor belt is very important for our climate. This term describes a combination of currents that result in 4 of the 5 global oceans exchanging water with each other. They form a worldwide circulation system. The conveyor belt is also called the thermohaline circulation, with thermo referring to the temperature and haline to the salt content of the water. Both determine the density of the water. While the masses of water may be moved in part by wind, primarily the different densities of the global oceans are responsible for their movement. Warm water has a lower density and rises, while cold water sinks. The water's density also increases with a higher salt content. At the equator, the heat from the sun is especially strong, resulting in a lot of evaporation and thus a rise in the water's salt content. That is where the Gulf Stream begins. The Gulf Stream is very important for the European climate. Its length of 10,000 kilometers makes it one of the largest and fastest ocean currents on Earth, and it's very warm. At roughly 2 meters a second, it brings up to 100 million cubic meters of water per second towards Europe. A constantly blowing wind, the southeast trade wind, drives warm surface water to the northwest into the Gulf of Mexico, where it heats up to 30 degrees Celsius. The turning of the Earth and the west winds then direct the Gulf Stream towards Europe and split it up. One part flows south, another east to the Canary Current, and a third part flows north, where it releases a lot of heat into the atmosphere as the North Atlantic Current. The water becomes colder there. Its salt content and density rise on account of evaporation, and it drops down between Greenland, Norway, and Iceland. There we also find the largest waterfall on Earth, the so-called chimneys, roughly 15-kilometer wide pillars with water falling up to 4,000 meters. 17 million cubic meters of water per second, or roughly 15 times more water than is carried by all the rivers in the world. This creates a strong maelstrom which constantly pulls in new water and is the reason that the Gulf Stream moves towards Europe. Countless species use the Gulf Stream as a means of transport on their trips from the Caribbean to northern areas. But it doesn't just bring us animals. An enormous quantity of warm air also comes with it. In order to produce the same heat which it brings to the shores of Europe, we would need 1 million nuclear power plants. That's why we also call the Gulf Stream a heat pump. Without it, the temperature would be significantly colder here, at least 5 to 10 degrees. Instead of lush fields, we would have long winters and sparse ice-covered landscapes in Europe.
All right, well, that's the presentation. So, Bill, did you want to do anything with that?
Any questions? Comments?
Okay.
Yeah, let's say, I was reading that there's like 4 trash islands. I guess the current and the wind cushions in that area. Do you think that he thought that?
Well, I understand that there are, and we can see we can visualize the way some of the currents go in circular motion and kind of suck things into it. So I could definitely see how that.
Kind of like where those boats got stuck, stuck there.
Well, okay, that's a good question. Where the boats got stuck, if you, I showed you this book about the physical geography of the seas. I was just kind of scanning that book, and he shows where some of the wind currents kind of have opposing forces, and there's certain areas where there's no wind because they equaled each other out. And so being aware of that, and these currents are more or less fixed. They will vary during the different seasons, but basically from year to year, they're going to be pretty much the same, so you can avoid those. I would think that would be a little different than accumulation of the trash, because and we're also talking about difference between wind currents and surface surface currents. Good question. Any other questions? And by the way, I'm not a scientist, I'm not an expert, I'm just a guy, okay? So I just, read this before you did, so that's why I know it, okay?
So with all of the publicity related to global warming, I was wondering if there's been any kind of impact on these currents that any scientist is aware of.
Okay, as far as global warming, it's a big political controversy of not only is it happening, but what are the sources and what would be the what to do about it, if anything. There is concern in Europe because they're saying that if the poles warm up, that Gulf Stream would not be as strong or might even die out because of the convection. There wouldn't be such a difference between the cold air at the poles and the cold waters in the poles compared to the equator. So they're concerned that that could die out, and then you would have other impacts, and it would actually get colder. So global warming in the northern areas could actually cause Europe to get colder because it wouldn't bring as much heat from the equator. So it's a good question. Yeah, there are all these impacts. Okay, anything else?
You didn't talk about that called the Dragon's Triangle, when the boats aren't even allowed to. Can you talk about it?
I don't know about it, but that might be a good message for you to present to the group sometime. I don't know about it. We do have did we get copies of the questions, Bill?
Yes.
Oh, did we pass these out? Oh, okay. I don't have a copy myself, so I don't know what they are.
Any more questions or comments?
Okay.
Is there any impact marks for meteors in the ocean?
Hold on. I'm sorry.
Well, there's a lot of scientists that are verifying that it's getting colder, not warmer.
Right. So I wanted to avoid a conversation about global warming. It's kind of beyond the scope of this, and I'm not any more qualified to talk about anybody else here. But there's a lot of political things involved in that as well. So, I'm sorry, what was your question?
Is there any impact marks for meteors under your ocean? I know they're finding ancient civilizations under the ocean.
That I couldn't tell you. I don't know. I understand that there's a lot of speculation, but I don't know anything about that. Anybody else?
Do those currents extend all the way from the surface to the bottom, or is it just a couple hundred feet, and then below that there's a totally different stream going in a different direction?
Well, he showed that one current up in northern Atlantic. That's a huge river, a vertical river going down of the cold water. I don't know how far down it goes, or any of that. Basically, this is pretty superficial level of this stuff, but it's, I don't know. I'm sure the information's there, but I don't know the answer to that. If there's no more questions, do you have your question sheets? Okay, so let's see. Who wants to win a new car? Yeah. I do too. That doesn't have anything to do with what we're doing. I just curious. Okay. Okay. What is the Bible verse that assured Maury that there are paths in the sea to discover? Did somebody say Psalm 8:8? Oh, good. Okay. Okay. Why didn't Matthew stay on the farm and help his father in the field? Fell out of a tree, didn't he? Okay. And why was Matthew disappointed with his first cruise?
There was no instruction work in.
Yeah, no real good training at all. Okay. Let's see. And how did Matthew use chalk and cannonballs to educate himself? Raise your hand. Okay.
It's spherical geometry.
Spherical geometry. All right. If there was a new car, okay. But there. Okay. Yeah. So he if you do like trigonometry, or if you do geography where you have lines that connect and so on, it makes a difference if it's on a flat surface than if it's on a spherical surface. That's why he was able to get insights that had been just overlooked and not seen. So, when the Lord set him up, he had to drop him out of a tree, he had to put a stagecoach on him, but he got him into that area. He had him prepared with the spherical geometry, and that should just encourage us and help us to realize when we have bad things happen in our lives, we just need to trust in the Lord. He says that anything that happens to his people is going to be for their good. So we just have to trust him. All right, and at some point we look back and we go, oh, that's why all that happened. Okay, so what protects the Earth from deadly solar eruptions? Okay, magnetic field, right. Okay, and what is the biggest driver of surface ocean currents? What's the main thing that drives surface? Now, not the deeper ones, but the currents at the surface. Okay, I'm hearing the sun. Anything else? I hear wind. It's wind. Okay. The convection currents would drive the deeper. The convection would drive the deeper currents, I believe. Okay, and what causes the wind to blow? Okay, seasons, sun, but there was what do we call that? Well, there's it kind of sounds like candy. Convection. Okay, convection. Okay. What is heavier, cold water or hot water? Cold. Why? Did somebody say density? Yes, thank you. Okay. And what is a convection current, and how does it keep our planet at a fairly even temperature? Okay, raise your hand if you know the answer. Okay, well, a convection current, if you remember that first chart that we saw was wind currents, right? The cold air was blowing towards the equator, and the warmer air from the equator was blowing toward the polar region. So the Lord evens out the temperature on Earth by setting up these air currents, these air circulation. Okay, what two things does a sounder tell us? Okay.
The nature of the ground.
The depth and the nature of the ground. Right, perfect. Okay. And, we kind of covered this briefly. Let's see if you caught this. What did Matthew say about the relationship of the Bible to science?
The Bible is scientifically accurate.
The Bible is scientifically accurate. That is true. But there was something specific that he said about it. It was kind of hard to catch.
He said they were both true.
He said they're both true and they each prove the other. Okay? Now there was a question that I was going to put on here, but I didn't, but I'll ask you guys. Okay? If a sounder falls at the bottom of the ocean and no one hears it, is it still a sounder? Okay. The answer is yes. Okay. So that's it. Should we close in prayer? Or do you have an announcement or anything left to do?
You pray, I'll do a quick announcement.
Okay. So let's bow our heads and close our eyes. Father, we just thank you, Lord, and praise you for the environment that you created for us. God, that you just put us in these bodies so that we are just perfectly adapted to the earth, and the earth is perfectly adapted to us. God, we just thank you and praise you for your word, and that we can trust you. And the more we look into it, the more we investigate, the more we see how true it is. And God, thank you for your creation and the fine-tuning and how you just show yourself to be so far above us. And thank you for the salvation we have through Jesus Christ our Lord. And God, we just ask that you would help us to be bright lights in this dark world. We ask it all in Jesus' name. Amen.
Amen.
Thank you.